Hi, and welcome to CodingCraft. Today, we're solving the meta puzzle Missing Mail, Level 2. It's a dynamic programming problem with a twist. We'll use pruning to keep things fast. Let's go through the logic and then build a clean Python solution together. Here's the task overview for Missing Mail, Level 2. We're managing a mailroom over n days. Each day a package may arrive. We can decide whether to enter and pay the cost C to collect everything, and at the end of the day, there's a chance all packages are stolen with probability S. Our goal is to maximize the expected profit, the total value we collect minus the entry costs. The constraints go up to 4,000 days, so we need an efficient solution, not brute force. Let's see how we can approach it. Here's the key idea. We describe the problem in terms of states: profit, stash. Profit is everything we've collected so far, and stash is the expected value of what's still in the mailroom. Each day, we have two choices: take, collect everything, pay the cost C, and reset stash to 0. Or skip, add today's package to the stash, but discount it by the probability of theft. To keep this efficient, we prune. We only keep take states that improve the best profit so far, and we drop skip states that can never catch up. This way, we avoid exponential growth while still preserving all optimal solutions. Here's the complete Python solution. We loop through the days, and for each state we either take, collecting all packages and paying the entry cost, or skip, leaving today's package in the stash with theft risk. Pruning ensures we only keep profitable states, which makes this solution efficient while still passing all test cases. And as you can see, it successfully solves all 24 meta test cases. Let's wrap up with why this works and how efficient it is. Without pruning, a brute force search explodes to 2 to the n states, totally impractical. With pruning, we keep only states that still have a chance to beat the best, so the frontier stays compact while preserving all optimal paths. In terms of complexity, the worst case is about O(n)², but it's usually much faster in practice, and the memory use is only O(n). That's the key takeaway. Smart pruning keeps our dynamic programming both correct and fast. Thanks for watching. Don't forget to subscribe for more coding puzzles and solutions. You can find the full source code on GitHub and check out more puzzles on the CodingCraft YouTube channel. See you in the next video.